Welcome back. A long time I does not upload a video about the machine learning and also deep learning. Now in December 2018, I want to make my last video in 2018. It's about building neural network with Keras. Building Who am I? Anh Xuân Chia, Microsoft MVP trainer and also speaker. Other than that, I'm certified in MCSA Cloud Platform and MCSE Cloud Platform and Infrastructure. And lastly, I'm co-organizer of Malaysia Mobile.net Developer Group. I'm currently based in Singapore, and I always fly back to Malaysia, Kuala Lumpur, to organize my meetup of Malaysia Mobile Developer Groups. Other than that, I am also interested in cloud security and application security. Okay, for today's objective, we need to create a Jupyter notebook in Azure notebook using Keras to build and train a neural network to perform sentiment analysis. Use the neural network to analyze text for sentiments. Okay, for prerequisite, you must have an active Microsoft account. Okay, what actually about building neural network with Keras? Building neural networks is not easy, even with popular libraries such as Microsoft Cognitive Toolkit and TensorFlow to help out. It often requires several hundred lines of code to get a neural network up and running. The one reason Keras has become popular in the deep learning community. Keras is an open source Python library that dramatically simplifies the building of neural networks. Under the hood, it uses the Microsoft Cognitive Toolkit, TensorFlow, and Tunnel to do the heavy lifting. With Keras, you can build sophisticated neural networks with just a few dozen lines of code and train them to classify image and analyze text for sentiment, do natural language processing, and perform other tasks at which deep learning excels. Okay, in this demo, you will use Keras to build a neural network to score the text for sentiment. Okay, let's go for demo. Okay, at first I already create one project in my Jupyter notebook. It does not need a course. Then you can automatically you can create the project for Keras. Then after that, you need to create one notebook with the name of keraslab.ipymp. Yeah, you can see it here, Keras Lab, and it belongs to Python 3.5 notebook. Okay. After that, you run the Keras Lab. Click the Keras Lab notebook. Then it will launch the notebook and I will allow you to start editing it. Okay. But today I will share with you about you will use the Keras to build and train the neural networks that analyze text for sentiment. In order to train a neural network, you need to You need a data to train it with. Rather than download an external dataset, you will use the IMDb Movie Review Sentiment Classification dataset that include third class. The IMDb contains 50,000 movies reviews that have been individually scored as positive or negative. The dataset is divided into 25,000 reviews for training and 25,000 for review for testing. The sentiments expressed in this review is the basis for which your neural networks will analyze text presented to it and score it for sentiment. Okay, let's go for our first comment. This code load the IMDb's dataset that included Keras and create a directory mapping the words in all 50,000 reviews and to integer indicating the word's relative frequency of occurrence. Each word is assigned a unique integer. The most common word is assigned the number 1. The second most common word is assigned the number 2, and so on. The loop data also returns a pair of tubes containing the movie reviews and the 1 and zeros classify those reviews as positive and negative. Okay, after you run the application, you will see that the message using TensorFlow backend indicating that Keras is using TensorFlow as its backend. Ignore the warning message. Okay, let's go for the second line. The second line we only type string 0. Okay, the reason the inner list contains a number rather than text is that you don't train neural network with text. You train it with numbers. Specifically, you train with tensors. In this case, each review is a one-dimensional tensors containing integers identifying the words comprising the review. Okay, after that, you run the command. It will show you the first number in the list. 1 does not represent word at all. It must the start of the review is the same for every review in the dataset. The number 0 and 2 are reserved as well, and you subtract 3 from the other number to match an integer in a review to the corresponding integer in the dictionary. The second number, 14, reference the words that correspond to the number 11 in the dictionary. The third number represents the words assigned the number 19 in the dictionary, and so on. Okay, we type third comment. This one only and also the result only a subset of the dictionary entries are shown by it all. The dictionaries contain more than 88,000 of words and the integers that correspond to them. Note that the output you see will probably not match the output at the screen because the dictionary is generated each time root data is called. Okay, now we type another comment. in the output mark as beginning while okay. As you've seen, each review in the dataset is encoded as a collection of integer rather than words. It is possible to reverse encode a view so you can see the original text that comprise it. In the output, you will uh, you will see the this word unknown are represented by 2 seconds in the list of the integer representing a view. Remember the number parameters you pass to root data. This is when it comes into play. It does not reduce the size of the dictionary but restrict the range of integer used to encode the reviews. Okay, in line 16, the reviews are clean in the sense that letters have been converted to lowercase and punctuation characters removed, but they are not quite ready to train a neural network to analyze text for sentiment. When you train a neural network with a collection of tensors, each tensor needs to be same length at present. The list represent review as trained and as test have varying lengths. Unfortunately, Keras, including a function that takes a list or list as input to convert the inner list to a specific length by truncating them is if necessary or padding them with 0 seconds. Enter. Okay. After we train and test the data, it is time to build the model. Run the following code in the notebook. Okay, run this one. After that, this code is the action of how you construct neural network with Keras. Okay. After that, we need to call the fit function to train the neural network. Then training should take about 6 minutes or a little more than 1 minute per apple. Apple finds tell Keras to make 5 forward and backward pass through the model. With each pass, the model learns from the training data and measure weighted how well it learns using the data. Then it make adjustment and go back for the next pass and apple. This is reflected in the output from the fit function, which show the training accuracy and validity accuracy for each apple. Batch size equal to 1 to 8 tell Keras to use 128 training sample at a time to train the networks. Larger batch size speed the training time, but smaller batch size sometimes increase accuracy. Okay, the most important is visualize the data after you train the data. Okay, the lastly, we need to finish up by calling a model evaluate method to determine how accurately the model is able to quantify the sentiments expressed in text based on the test data as text and white text 0 and 1 or label indicating which reviews are positive and which are negative. You'll probably achieve an accuracy in the 85% to 90%. Okay, at last, we need to come to a real test. The real test when you input of your own into the model and see how it performs. That is how adept it is at quantifying sentiments expressed in that test. Okay, this statement in line 13. This statement defines a function named analyze that accepts as a string as input, return a number from 0.0 to 1.0, quantifying the sentiment expressed in that string. The higher the number, the more positive the sentiment. The function brings the input string, convert it into a list of integer referencing words in the dictionary created by the loop data function, and finally call the model's predict function to score the text for sentiment. Okay, in line 14, the output is the sentiments expressed the input text as a number 0.0 to 1.0. Would you agree with that model? In line 15, finish up this. How does the model quantify the sentiment expressed in this text? Finish out by testing model with input string by your own. The result won't be affected, but you should find that model is reasonable adept at quantifying sentiment. Note that even though the model was trained with movie review, it does not limited to analyze movie reviews. That makes sense because there are inherent similarity between language expressing the like or dislike of a movie, words expressing feeling about other and perhaps completely unrelated subject. Okay, now come to a summary. Keras made it remarkably easy to build and train neural networks to perform a wide range of deep learning tasks. It does not absorb you from understanding various neural network architecture, know what type of layer to include in a network, and the size of those layers, or for example, understand the role of activation function and when you apply activation function of different type. But once you have determined what to build, a few lines of code generally get the job done. Moreover, class allow you to experiment with different network architecture and implementation rather quickly compare the result. That's all for my today demo. Please follow my Twitter. If you got anything, you can message me in Twitter, and remember, like this video, share this video with your friends, and press the bell when I upload a new video. Merry Christmas to everyone.